So this is a 2.9. This is percents, which I'm pretty confident most of you guys have done a lot of this before. So I'm going to show you guys how percents relate to what we've been studying with proportions, okay? So write this down. You've probably seen this before as well. See if I can get the stars to match up. There we go. So percent over 100 is equal to is over of. So go ahead and write that down. Percent over 100 equals is over of. So there's an is part, there's an of part. What some students get confused about is sometimes the is part can be bigger than the of part. For example, if I'm investing money in a mutual fund, I would hope that the is part would be bigger than the of part because I want to make money. I want to at the end of the year have 100 and something percent of what I started with, not less. It could be less. But if I'm in a savings account with 3% interest, I want 103% at the end of the year. That's actually a little bit more because banks compound monthly, right? So you get a little bit more than the end of the year 3% because each month you have another compounding which gives you a little bit more. So percent over 100 is equal to is over of, and here we have percent over 100 equals part over total. Just understand that the part can be bigger than the total at times, right? For example, as you're going through your classwork, you're going to get some percentages like 500% or 250% or something like that. It might be, if you're in business, you might buy something wholesale and mark it up 200%. That would mean twice of what you bought it for, so that you're making as much money as you spent on it. So that's the idea. So then you can go buy two the next time. And so that's how you make money. So percent over 100 equals part over total. Just get a big idea on how you can make some money. If you go into business, you want to sell things for more than what you bought them for, and then you make things. So now, if I'm out, I'm out shopping. Probably would happen. If I'm out shopping, it must be Christmas time or birthdays. Kids, but if I'm out shopping and I go and I buy something and I want to figure out how much I'm going to pay in tax, what I would do is just do 8% of whatever the cost of the item is. So if I'm buying a $20, gift, my tax is going to be 8% of $20. I'm not going to set up a proportion to do that. What I'm going to do is hit 0.08 on my phone calculator or whatever in my head, kind of think about it, times 20 and then figure out what the tax is. Or if I'm out to dinner and I have to pay tip, a couple ways you can do that. You could double tax, because tax is about 8%, double that would be an appropriate, 16% appropriate tip. Or you could go, okay, if my bill is $60, I'm going to take 15% of $60 by just going 0.15 times 60, and that's how much you're going to pay for tips. So there is a percent equation. It works like this. It's just the part, or the A amount, is equal to P% times B. So if you want to know, how much, what's the amount of the tax, you do 8% times whatever the item costs. Or if you want to know tip, it's going to be 15% times whatever your bill was. Okay, if you want to know the sale price of an item, say the item's 70, actually it's 30% off. Okay, probably not 70% off unless it's they're really trying to get rid of it. 30% off. Then you're actually going to pay 70% of the original price, right? Because 100 minus 30 is 70, so I do 70% times the cost. So that's the idea. Here's the other way it works. So either I'm going to multiply the percent times whatever the item is that I want to know the tax or tip or whatever the new price is, or say you're taking a test, you just got a quiz back, right? Suppose you got 17 out of 20 on your quiz. How could you find your percentage P for that quiz? What would you do with the B? Divide it. That goes back to those one-steppers, right? I would take this B, because it's being multiplied by P%, I would divide it. So 17 out of 20, you'd go 17 divided by 20. and it would show up 0.85 on your calculator. What does that mean? 85%. That's the hint here. To change from decimal to percent, multiplied by 100. So when you see that 0.85, you know it's 85%. And then you go, oh, well, 17 out of 20 is 85%. 85% means I got a B on this quiz. Okay, so you see how that works? So with this percent equation, this is what we use in real life. People are going to either multiply the percent by the cost of the thing, or they're going to divide these two numbers and get the percent. It's one or the other. And you can do it all with your phone calculator right there. Sometimes you can do it in your head. Here's an example. If I went shopping, I bought this item for $20, a gift for $20. What if they said, actually you can have, you know, it's on sale, it's 30% off. What would I expect to pay for the item, the $20 gift, if it's 30% off? Well, what's 10% of $20?
10.
Not quite. $2, right? And 30% would be 3 times that, so I'd go 2, 2, and 2, or $6 off. And so the cost would be $14. So when they're multiples of 10, oftentimes we can do that in our head and kind of get an estimate at least. Something like tax at 8%, I just usually think, oh, 10%. We'll probably be there someday anyway, because our taxes in California, sales tax in California just keeps going up. But so we've got, you can always estimate and do that. So there's our percent equation. Say you want to calculate your interest. You invested $1,000 at 3% interest for the year. And you want to estimate your interest at the end of the year. You just multiply the principal, which is the $1,000. Instead of typing in 3, I would type in 0.03 for percent, and then times 1, and that would give me an estimate of my interest at the end of the year. I say estimate because banks take your 3% interest, and what they do is they divide it by 12, because they're 12 months a year. 3 divided by 12 is 0.4, so they apply 0.4% each month. So they'll take 0.4% of your $1,000 and you'll get $4 out of that. So then, but then the next month they take 0.4% of $1,004. So that's a little bit better than what simple interest gives you. Okay, it's going to keep telling me my performance is slow. Oh boy. All right, so that's the interest equation. So we're going to go through today, and we're going to set up proportions where x is in the percent category, where x is the is part and x is the of part. All right, on your sheet, it's already all filled out for you, although I noticed some of them it didn't copy very well. So just to make sure you have all these common percent as decimals and fractions. First one is 1% is 0.01. Second one, 5% is 0.05 or 1/20th. 10%, don't get that confused with 1%. It's 0.1, not 0.01 or 1/10. Make sure you have those top three. I think those are the three that didn't copy as well. And then the rest of the table, you have it all filled out there on your notes. So these are some common percents all the way down to 100%, which is equivalent to the fraction 1. So those are some common percents. It says find a percent using the percent proportion. It says what percent of 56 is 42? So in this case, this is the first of our examples. Where does the x go? Does it go in the percent category, the is category, or the f category?
Definitely the percent.
Percent. We don't know the percent, right? So we have x over 100 equals, and then which is the is part, or the part here? Yeah. The 42. So it says what percent of 56 is 42? So in this case, the 42 is the part, and the part is actually less than the total. We cross multiply. This is how it connects to what we've been doing. We cross multiply. 56x equals 4200, and then we divide. And you divide each side by 56. 4200 divided by 56 is
A lot.
75, and this is a 75% that I'm getting. Okay, so 75%. What percent of 90 is 30? That you might be able to answer without even setting it up. X over 100 equals 30 over 90. What fraction of 90 is 30?
1/3.
1/3. And what is that as a decimal?
0.3 and it's infinite.
Yeah, it is. And so as a percentage, it would be what percent? About 33, yeah. It's about a third, right? So let's see here. We've got 90x equals 3 with 1, 2, 3 zeros. So x equals about 33.3%. There's a bar over it. It keeps repeating. That means it's exactly equal to 1/3. So you could say 33.33%. If I'm investing a bunch of money, which I'm not, but if I happen to be investing a bunch of money, like, I don't know, millions of dollars, I would care if you rounded that off to 0.3 as opposed to leaving it 1/3. Because 0.3 is less than 0.33, right? And if I have a lot of money in there, that 0.03 could make a big difference in the long run. But I don't have a lot of money in there, so it doesn't matter. But 33.3% or 33.33%. All right, you try these two. So see if you can set them up and solve, and then I'll throw up the answers here in just a minute. Okay, so you should have gotten 60% for this guy, 90% for this one. All right, this is finding a percent using a percent equation. Because that percent equation is on the first page, I'm going to write it down again here. So it's A equals P percent times B. So this is kind of like the problem that I quoted with your quiz score. Okay, what we're trying to find here is the P percent. We know the amount is 2.5. We don't know P, and the whole is the 40. So if this were a one-step algebra equation, which it is, what would you do to solve for P? Divide. So P is going to be equal to whatever 2.5 divided by 40 is. And so it's just like what we did with the quiz. So when you're trying to find the percent, you take the part and you divide it by the total. And that'll give you your percent. On this one, what do you get? Okay, so it ends up being 0.0625. And then when I move the decimal 2 places over, I get 6.25% is what my P percent is. So, you could set up like that. What could you do on the now you try? You could do it all in one step. Divide. Yeah, that's right. Just take, 63 divided by 84. That's going to give me a decimal. Yeah, I don't need squiggly equals. It gives me an exact decimal of 0.75, and so that's 75%. You're done. So real easy to do with that percent equation. I'm going to let you use that on some of them. Other ones I'm going to ask for the proportion, just because of the way it connects to what we've been doing. All right, so we've looked at solving for P percent. That's where the X is in the up above the 100. Let's go on here. What about finding a part? So this is going to move the X over to the is part. It says a dress shirt that normally costs $38.50 is on sale for 30% off. What is the sale price? So we're going to do this first in 2 stages. We're going to take and write 30 over 100, because it's always percent over 100, equals the is over the of part. So, or the part over the whole, or in this case, it's like the sale price over the original price. So we have X over 38.50, where 38.50 is the normal or retail price, if you will. So when I solve this, just understand that what we're finding is the amount of money we're going to take off of the original. So when I cross multiply here and solve, what do I get? If you could do the cross multiplying and dividing for me, what do you get? Yeah, and that equates to $11.55. So make sure you have this decimal in here, but $11.55. That's off. That's not what the new price is. That's what you take off of the original price. So if I take $38.50 and subtract $11.55, I'll get my sale price, which is good, $26.95. So that's doing it using proportions. There's a more efficient way. Anybody catch that? If it's 30% off, what percent do I have to pay? 70. So another way to do it using the formula would be 0.70 times 38.50. And what do you get when you do 0.70 times 38.50? What did you notice? We get the same thing, $26.95. So, that's a more direct way of getting it. Now you could use that when you're out and about and just go, 30% off, that's the same as 70% of the original price. All right, go ahead and see if you can do the now you try part for this car. Tell me, whichever way you want to do it. So that once you get that 5,400 that you take off, and you subtract that from 9,000, you get 3,600. And of course, the other way to do it would be, well, if it's 60% less than what they paid for it, it's worth 40% of what they paid for it. So 40% of 9,000 would also give you $3,600. So there it is. So that's when X is the part. What about when X is the base? It says 125% of what number is 17.5. So we'd have percent over 100 equals the is part is given to me, 17.5 over x. Now this one's interesting. 125% of 17.5 is going to be, of some number, is going to be a number that's less than 17.5. See, the 17.5, I didn't say that right. The 17.5 is the 125% of some number. So the 17.5 will be bigger than what we get. Okay. So if you go ahead and solve this by cross multiplying, and then x equals, what do you get? Did you get 14? Yep, that's right. So 17.5 is 125% of the number 14. Second one here, we have 25 over 100. This is of what number is 10? So the 10 over x here. Go ahead and cross multiply and solve that one for x. Some of you might be able to do this without cross multiplying and dividing. 25% is like 1/4. 10 is 1/4 of what number? 40. So x equals 40 is what you should get. So go ahead and try the now you try ones there, the last two. So for the first now you try, you should have gotten 41.7. 41 2/3, and the second one was 100. All right, the last one on here is just using that interest equals principal times rate times time. So here's my principal P, here's my rate R, and here's my time T. Now my rate, when I go to do my rate, I need to change it to a real number. So I take 4.5 and I move the decimal 2 places to the left, and my new number is 0.045. So that's what I'm going to use for my rate. So you got to carefully change that. When you're dealing with money, a lot of times the interest rate, unfortunately, is less than double digits. So you'll have a 0.0 something oftentimes. So interest here would be, principal is $840, rate is 0.045, and then time is 4 years. Although if you're taking out a loan, you do want the interest rate to be lower. And if you're investing money, you want it to be the other direction, right? So can you go ahead and calculate the interest? What's the interest I would earn in 4 years? $840 at 4.5%. 4.5% would be a high interest rate to get right now.
151 and 20 cents.
That's right, 151.20. So why don't you try this one right here, see if you can get the right. The only trick here is getting the correct rate here on that 1.75%. But see if you can do this next one here. So yeah, this one is a little different. Maybe I'll write it down here. We are solving for t. Right? So we've got an I, let's see, you earned an interest of $875. Your principal was $125. Your rate is, can you change this to a real number? What would it be?
1.55.
We're going to move the decimal 2 places to the left.
0.0175.
0.0175, that's right. Times t. So, going back to our one-steppers, how do I get t by itself? What do I have to do to each side? Well, not quite subtract. This is good. That's good. Yeah. Well, you're thinking right. Inverse operations, but what does this mean when you have parentheses next? Yeah, you got to divide each side. So divide by 125 times 0.0175. That will get rid of it there. Divide this side by 25 times 0.0175. If you wanted to do the multiplication first, you could. So t is equal to whatever 8.75 divided by 125 times 0.0175 is. Got to be careful when you type that into your calculator. If you type it in all at once, you would need to put parentheses around the 125 times 0.0175 so that it doesn't just divide by 125 and then multiply by 0.0175. Should get a number of years, a whole number here. You should get t equals 4 years. And that's it. So go ahead and write your summary.